right. So let me actually share my screen. So in the last week, actually, we had discussed about Y delta transformation. Today we'll be actually discussing some circuit network theorem in AC circuit, but all the theorems have had been actually covered in DC circuit. So whatever we have learned in DC circuit theory, these theories will be applicable in AC circuit as well, as I mentioned earlier. So one of this actually theories was like the superposition theory, so or the superposition theorem. Do you understand what is it actually called, the superposition theorem? কি বলতে পারেন?
স্যার একটা আরেকটার উপর মানে আপতিত বা সমপতিত হয় এই জন্য।
Okay, that is actually the meaning of superposition, but the superposition theorem in AC or DC circuit or electrical circuit means if a circuit if a circuit actually contains multiple sources, it may be voltage sources or the current sources, then the total response at a certain actually branch or certain component, it could be in a voltage, it could be in a current, should be equal to the responses coming from each and every sources. It's জিনিসটা এরকম, ধরুন হচ্ছে আপনারা একটা ফান্ড গঠন করলেন, সেই ফান্ডে হচ্ছে কিছু টাকা আছে, ধরুন 10,000 অথবা 20,000 টাকা আছে। তো সেই জায়গায় 5 জন হচ্ছে ডোনার আছে। তো 5 জন ডোনার যদি থাকে, তাহলে 5 জন ডোনার কিছু টাকা হচ্ছে ইনভেস্ট করছে অথবা কিছু টাকা হচ্ছে সে ডোনেট করেছে। সো টোটাল যে টাকাটা, সেই টাকাটা হচ্ছে প্রত্যেকটা ডোনারের কাছ থেকে আসা টাকার হচ্ছে সাম। তার মানে হচ্ছে ওই 10,000 যে টাকাটা আছে, সেটা হচ্ছে ওই 5 জন ডোনারের কাছ থেকে আসছে, তাদের হচ্ছে সাম। এটা হইতে পারে কোনো ডোনার 7,000 টাকা দিয়েছে, কোনো ডোনার 2,000 টাকা দিয়েছে, কোনো ডোনার 1,000 টাকা দিয়েছে, or কোনো ডোনার 100 টাকা দিয়েছে, something like this. So but the total sum should be 10,000 actually taka. Similarly, in our electrical circuit, if we have actually multiple sources, it could be voltage sources, it could be current sources, or it could be DC source or AC source. Then if we are asked to calculate certain electrical responses, mostly these are actually current or voltage, then the total contribution should be equal to the algebraic sum of the actually electrical response produced by each and every sources. So what does it mean? That means if I consider a particular source, at that time other sources will be deactivated, means other sources will not be in effect. So this is the very basic of actually superposition theorem, and probably you all have learned this thing actually in this circuit. So why actually the superposition theorem is important for AC circuit, or like analyzing voltage or current in a circuit. So in DC circuit, I don't know, why that is so important, but in AC circuit, superposition theorem is very much actually needed because because AC circuit, the sources could be frequency dependent term, means as we know, like if I have two sources, one voltage source, another voltage source, let's say, let me actually draw something. Today I'm not using my typical like laptop, so it would be difficult to design this. Like let's say this is a AC source, then we have a resistor sort of things, and then let's say I'm holding another AC source, and perhaps there are some inductor and then capacitor or whatever we have here. So let's say this is inductor, and there is some capacitor as well, sorry, capacitor and then inductor as well, and something like this. It's a very simple circuit, but we have two sources. This voltage source or this current source is having a frequency of, let's say, f1, and this one is having a frequency of f2. So that is actually quite interesting. Like, we have two sources, two electrical sources. It could be actually voltage source or current source, but they are not having the same frequency. Then everything will be different. Especially if frequency changes, then the reactance or the inductance or the impedance of capacitor and impedance of inductor will change with respect to frequency, right? So this is XL. Now, can anybody actually tell me, if I have two frequencies, like so far, whenever we are solving a electrical circuit or the AC circuit, we had always a single frequency, means the source will be having the same frequency, j omega t or
স্যার ওটা কি
ft or something.
স্টেডি স্টেডি স্টেট বলে ওটাকে নাকি?
Which one?
মানে আমরা যে আমরা তো সবসময় ধরে এসেছি যে একটা কারেন্ট একদিকেই যাচ্ছে,
হ্যাঁ
মানে এসি সোর্সে যেমন দুই দিকেই তো কারেন্ট যায় মূলত,
হ্যাঁ
কিন্তু
হ্যাঁ
আমরা যেসব ম্যাথ করে এসেছি সেগুলোতে তো মানে একদিকেই যাচ্ছে, সেটা কি স্টেডি স্টেট অ্যানালিসিস বলে?
আমরা যেগুলো হচ্ছে ম্যাথগুলো করেছি সেগুলোর মধ্যেও হচ্ছে এসি এসি হচ্ছে সিগন্যাল ইউজ করেছি, যে জায়গায় হচ্ছে কারেন্ট দুই দিকে ফ্লো করতে পারে। বাট যখন আপনাদের সার্কিট সলভ করতে দেওয়া হয়, আমরা হয়তো বা প্লাস মাইনাস পোলারিটি বলে দিই, এই পাশ প্লাস ওই পার সেকেন্ড, তার মিন অথবা কারেন্টের ডিরেকশন বলে দিই। দ্যাটস মিনস ওই ডিরেকশনে কতটুকু কারেন্ট ফ্লো করে সেটুকু বের করার জন্য। এটার অর্থ এই নয় যে অপোজিট ডিরেকশনে কারেন্ট ফ্লো করে না। যদি আমার ভোল্টেজের পোলারিটি চেঞ্জ হয়ে যায়, কেননা এসি সার্কিট মিনস একটা টাইম পর ভোল্টেজের পোলারিটি চেঞ্জ হয়ে যাবে, তখন কারেন্ট উল্টা দিকে হচ্ছে ফ্লো করবে। সো বাট আমি যেটা এখানে বলতে চাচ্ছি যে if we have actually multiple sources but having different frequencies, then this, like, the inductance value sorry, not the inductance value, the impedance of capacitor or impedance across actually the inductor will change, because we all know the reactance formula for inductor and in the capacitance. This is 2 pi fl, and for the capacitor is 1 upon 2 pi fc. Now if I change in the frequency, then XL will change and XC will change. This is very interesting case. For this actually circuit, since we are having actually two voltage sources with two different frequencies. Now, tell me which reactance value the circuit will have. Like, will it be 2 pi f1l or it would be 2 pi f2l? Because f1 and f2 are not equal, so that capacitor or that actually inductor will be experiencing actually different impedance value. So in that case, if I want to calculate what is the current passing through this or what is the voltage across this, then that will actually create some ambiguity initially. Although after sometimes they will actually settle a different frequency at which the circuit will be balanced. But in that actually situation, the superposition theorem would be really helpful. How? Like, we'll actually treat this frequency at a time, means we'll actually treat each and every voltage source independently. Means if I consider this voltage source, then we'll deactivate other actual voltage and current sources, or vice versa. Means if I actually consider this voltage source, then I will I'll ignore this voltage source, means set it to 0. Then we'll get the response here and there. Later on we'll be actually solving a few maths on it. So that's why superposition theorem is really actually important for solving the AC network, because we can treat each and every sources independently. And কিছু বলবেন আপনি, কিছু বলতে চাইবেন?
Sir, we are going to use superposition only in these cases when like the frequencies are different.
Exactly. Yes.
And so then in this case we can actually not use for example we want to find a voltage of a node, if I think, sir. So then
No
in that case it won't be workful if I use node analysis, right, sir? Something like that. Are you saying something like that, sir?
Yes. So what I'm trying to say, like আপনাদের এর আগে যতগুলো ম্যাথ করানো হয়েছে অথবা যতগুলো প্রবলেম করানো হয়েছে সেখানে হচ্ছে মাল্টিপল ভোল্টেজ সোর্স অথবা কারেন্ট সোর্স ছিল, বাট সেই ভোল্টেজ এবং কারেন্ট সোর্সের একটা মজার জিনিস ছিল, যখন আমি প্রথম ক্লাসের দিকে পড়াচ্ছিলাম, যখন ওই যে লিড ল্যাগিং পড়াচ্ছিলাম না, তখন একটা কন্ডিশন ছিল যে ওই ভোল্টেজ এবং কারেন্ট অথবা যেই সোর্স গুলো আছে যার সাথে যারটা কম্পেয়ার করব তাদের তাদের ভোল্টেজটা সেম হইতে হবে, সরি তাদের ফ্রিকোয়েন্সিটা সেম হইতে হবে, বলেছিলাম না? হ্যালো, ক্যান ইউ হিয়ার মি?
জি স্যার।
Yes, sir. That's why we can take
So-
it to phasor and then
So
have
yeah,
the
that
calculation.
that is so easy. Like we can actually express everything in terms of phasor. But if we have a circuit with different frequencies, we cannot actually convert it into phasor because we don't know which frequency are we actually considering. But if you want to solve that thing in PSpice or some other simulator or the real circuit, the circuit will set up a different frequency at which the circuit will be balanced, but we don't know what is that frequency. So in that case, what we could do, we can use we can take the help of actually superposition theorem. So if I consider only one source at a time, then there will be only one frequency, so there will not be multiple frequency present in the circuit. So if I have only single frequency in a circuit, we can use the KVL or KCL, means the mesh analysis or the node analysis or the source transformation or whatever to get that response. Let's say we want to calculate what is the response here, we can get that things, and then we'll repeat the same thing for other actually sources as well with different frequency. Then we'll get the response from each and every sources, and the final result would be the summation, algebraic summation of all of them. But apart from actually the AC contribution, there is another thing is called hybrid mode. Means we have a circuit with a DC voltage source. Let's say this is a DC voltage source. So sorry for handwriting today because I'm not carrying my
Sir, no problem, sir.
my general laptop where I could write. So this is my old laptop since I'm traveling. So this is the case. If I have a DC and AC source at the same time, and I want to know what is the contribution of DC source or the DC part, and what is the contribution of the AC part, then we can actually we can easily actually solve that thing with respect to superposition theorem, because when we consider DC source, all the other AC sources will be deactivated or other sources will be deactivated. So from that actually circuit configuration, we can get the contribution coming from actually DC. Later on we'll actually see some real examples for here. So now the question, is superposition theorem applicable to in finding all sort of parameters, electrical parameters or electrical responses such as voltage? What could be the electrical responses, like the voltage or current, or the combination of voltage and currents, such as the power, or such as actually what is it called, like energy or some other things. But remember, superposition theorem is only applicable for a linear circuit or linear circuit elements. That means if I have a voltage and current relation, which can be represented by y equal to mx plus c, means y could be voltage or current, or x could be voltage or current, then for that case we can actually use superposition theorem. Otherwise superposition theorem will not be applicable. So what does it mean? If we want to find out the voltage or current in a circuit, then we can use actually superposition theorem, because the relation between voltage and current is always linear. If we have capacitor, inductor, sorry, this one is the case. But how about the power? Power formula is P equal to V square by R, right? Or P equal to I square R. So in that case, we cannot actually apply the superposition theorem because the relationship is no longer, linear. Now I have a question. If I replace, although it's not a part of your actually course, but I want to actually add that part. So if I replace that capacitor or inductor or resistor with a nonlinear like circuit component such as diode or rectifier or like silicon control, rectifier or something like this. So in that case, can we apply superposition theorem if we have diode in our circuit?
Sir,
What
in
do you
that
think?
case, it
No,
will be
sir.
also no, because sir, there because
The relation is not actually the linear,
yes,
right?
yes,
Because
sir.
yeah, so we cannot actually like write down the equation in linear form. So yeah, another important actually application that I have already said, that to analyze the DC and AC effect separately, means the hybrid mode. If a circuit actually contains both the AC voltage source or current source, means the AC sources and the DC sources, then we are getting the resultant actually some contribution like the voltage or current actually values. But how much are coming from the DC sources and how much are coming from actually the AC sources, we can actually analyze using that the superposition theorem. And we all know for superposition theorem we need to take single source at a time. Means if we consider a source, the other source will be deactivated. So how would we actually deactivate actually sources in
Sir,
yes?
So we'll turn off that,
sir,
and actually instead we'll think as a wire actually on that part, like a open circuit, closed circuit.
All right, so the thing is
sir,
his
I have a question that
yeah, sure, go ahead please.
how can we ensure that capacitor and inductor are linear
Having
elements?
the linear elements, that is a good question. Like so
Sir, I'd like to add to it, like, sir, how will you understand like which will create non-linear equations?
thank you so much. Yeah, if you don't ask me in a question, then you can never get a clear picture. So do you understand this is a linear equation y equal to mx
It's
plus
like
c?
V equal to
Yes,
IR.
sir.
Yes, perfect. So c is the offset, right? So the graph is like this. So if I plot x here, excuse me for my handwriting today, please. So let's say this is y, and the graph is something like this, y equal to mx plus c, and this is nothing but the c, right? And the slope is m. So if I have some sort of relation, then only then we actually call it a linear equation. Now somebody actually posed a question like, oh, if I have a capacitor and inductor, we know the across resistor, the relation is v equal to IR, so that is linear, no problem at all, because for resistor the relation is like this, right? Like let's say this is I or V and this is I. The graph is like this, right? If this is a graph, then we know, certainly this is a linear equation. Now, how about others, like the capacitor and inductor? So I do understand what was your concern. Like we know that XL value equal to 2 pi FL, right? 2 pi then F times L. So here if I have that XL value with respect to frequency, that is a linear graph. How about XC? Oh, sorry for the handwriting. It's not, the mouse is not working as well. Give me a second, please. So XC equal to, we know the formula, right? 1 upon 2 pi FC.
Yes,
Hello?
sir.
Yes, sir.
Okay, I will write down 1 upon C only. That is proportional because I can't write the whole thing. So for this case, what is the graph with respect to frequency? Let's say this is frequency and this is XC. Then the graph should look like this. So this is no longer a linear graph, but still I'm saying the voltage current relation is linear in capacitor and inductor. How is it possible even? The answer is very simple. If we convert a capacitor, in the impedance diagram, the impedance should be nothing but the Z, then there's ZC, right? Okay. So now when you applied actually the node analysis or the loop analysis, the things you have learned, let's say that this voltage is nothing but the, let's say, VC. Tell me, what is the current passing through this? Just forget about superposition theorem, but you have already learned, the mesh analysis or the loop analysis as well as actually node analysis. So in that actually loop or mesh analysis or node analysis, there is a branch that voltage across actually this capacitor is VC is given, and the impedance of capacitor is just ZC. Then I ask you to calculate what is the current passing through that capacitor. What would be your answer?
Sir, VC by ZC.
How about other students? Like, who asked me a question? I don't know their names, but
Sir,
I
I
believe
asked.
yes. Abrar actually asked the question of like. So tell me, what would be the expression? What would be the relation? Then I will answer your question.
So
So VC by ZC.
VC by ZC, right?
ZC.
Because VC is the actually voltage across capacitor. So we'll be writing actually VC divided by ZC. That has to be equal to the current, and we are denoting that current by IC, right? Please excuse me for my handwriting because I'm not using pen once again. I'm really sorry for that. So tell me, if I rearrange this relation, then could I write VC equal to IC times ZC?
Yes, sir.
Yes,
What
sir.
sort of equation is this? Like voltage
It's
and current
linear. It's
relation?
linear. It's linear.
So if this is voltage and this is current, still it's a linear equation. The same sorry, this is not linear. Forget. It should be something like this. So this is a linear equation, right? So that's why the capacitor and inductor is still in capacitor and inductor. We will get linear response in terms of voltage and current. But if we plot actually the reactance, or how does actually the capacitor behaves with respect to frequency, that is different. For inductor, it's a linear actually relation, but for capacitor, that is not a linear relation. Actually, this part is causing the confusion, right? Like it's look like a non-linear graphs, but still we're saying actually we'll get linear relation. Am I clear now?
So it's like I equal to V by R.
Yes, perfect.
Right.
So now is it clear
So
why still?
Is it only related to the reactances and not the capacitance or inductance?
What
The
is that?
মানে এখানে তো আমরা মানে রিঅ্যাকটেন্সের হিসাবটা করলাম, কিন্তু মানে
ইম্পিডেন্সের ক্ষেত্রে
ক্যাপাসিটেন্স
কি হবে?
মানে ক্যাপাসিটেন্স যেটা ফ্যারাডে মিউ ফ্যারাডে যেটা হিসাব করা হয় বা
That
ইন্ডাকটেন্স
capacitor
যেটা
doesn't change. Look, yeah, that is a very good question. Like I believe since we are learning some AC circuit, we should have a very clear concept. Look, the capacitor is a material property. Our inductor is a material property. How the material is built means the capacitor is a parallel plate things. Like if you have used in the capacitor or you have seen actually capacitor in real life, so this is something like this. So it has a metal actually two plates, so that doesn't change. If you buy a capacitor, that will always be let's say 5 microfarad. That 5 microfarad will never change. But if you actually connect that 5 microfarad with a frequency which is different, then that capacitor will show different impedance. আমি আপনাদের একটা খুব ইজি এক্সাম্পল দিই। মনে করেন আপনি এখন বড় হয়ে গেছেন, আপনার বাসায় কতগুলো কাজিন আছে, গ্রামের বাসায় গিয়েছেন। তো একটা কাজিন ধরেন 7 years old, আরেকটা কাজিন 10 years old, আরেকটা কাজিন ধরেন 20 years old। তো আপনাকে বললো তো সবার সাথে আপনি ব্যাডমিন্টন খেলার জন্য, আপনি খুব ভালো ব্যাডমিন্টন খেলেন বাই ডেফিনেশন। তো আপনি 7 years old এর সাথে যেভাবে খেলবেন 10 years old এর সাথে সেভাবে খেলবেন না, যদি আপনি সব সিরিয়াসলি না নেন। and 20 years old এর সাথেও আপনি সিরিয়াসলি খেলবেন না, মানে হয়তোবা বেশি সিরিয়াসলি খেলবেন। সো আপনি ডিফারেন্ট ভাবে বিহেভ করতেছেন, আপনি কার সাথে খেলছেন, মানে কত এজ কার মানে অপোনেন্টের সাথে খেলছেন। সো সিমিলারলি ক্যাপাসিটি ডাজন্ট চেঞ্জ, আপনি চেঞ্জ হন নাই, বাট আপনি কার সাথে খেলছেন সেটার ওয়াইজ আপনি খেলা চেঞ্জ হচ্ছে। সো ক্যাপাসিটর অর ইন্ডাক্টর দ্যাট ডাজন্ট চেঞ্জ। but depending on actually the frequency, it changes its behavior or its reactance, the ability to like resist current or something like this, or creating heat. Am I clear now from the
মানে লিনিয়ার
this
ইকুয়েশন, লিনিয়ার রিলেশনশিপ বলতে আমরা এই রিঅ্যাকটেন্স
ভোল্টেজ
গুলোকে
এন্ড
বুঝি।
কারেন্ট রিলেশন? হ্যাঁ, ইয়েস। আপনি যদি বলি কখনো ইলেকট্রিক্যাল সার্কিটের হচ্ছে লিনিয়ার রেসপন্স আছে কিনা, তাহলে আপনাকে দেখতে হবে যে হোয়াট ইজ দ্য রিলেশন অফ ভোল্টেজ এন্ড কারেন্ট। আই এম গিভিং ইউ অ্যানাদার এক্সাম্পল দ্যাট উড বি রিয়েলি ইজি টু আন্ডারস্ট্যান্ড। লুক, let me actually draw. Give me a second. I need to actually talk to something. So yeah, I'm back again. I'm sorry again for the interruption. So the thing is, if I have a diode, let's say we have a diode. We have a diode, something like this. So now I want to know what is the current voltage relation. So the current voltage relation, I equal, let's say, some constant that is written as Vs. So this is called some sort of actually reverse saturation current, and then exponential term e to the power V A, or whatever that voltage across diode divided by Kt is the Boltzmann constants. Probably you have not actually learned about this, but you don't need to learn it in this actually course as well. So we say the voltage across the diode is Vd, and again the current passing through this is I. So the relation is V equal to I equal to Vs e to the power Vd divided by Kt. Now if I plot actually the voltage, if I plot the voltage current relation, that voltage and current relation, it would be something like this. It would be something like this. It's no longer linear relation. It's no longer linear relation. So that's why we are saying this is a nonlinear device, or any device contain actually the diode would be called as nonlinear device. And for that actually circuit containing diodes or any sort of actually nonlinear device, we can never apply the superposition theorem. Okay, even if I had actually enough time, I could actually explain why the superposition theorem cannot be actually applicable or in nonlinear devices, but probably it will take much time, and that should be enough whatever we have learned here. So now what
সব সময় কি স্যার ভোল্টেজের হিসাবে করব নাকি স্যার, যেমন আমরা ইন্ডাক্টর বা
voltage and
ক্যাপাসিটরের ক্ষেত্রে
voltage and current relation, যদি কোনো ইকুয়েশনে পান যে ইকুয়েশনে ভোল্টেজও আছে কারেন্টও আছে, দেখবেন ইকুয়েশনটা y = mx আকারে লেখা যায় কিনা। আপনি এই ইকুয়েশনটা y = mx আকারে লিখতে পারবেন না, কেননা এইটা যদি x হয়, এটা যদি x হয়, আর এটা যদি y হয়, তাহলে আপনি কখনো y = mx আকারে লিখতে পারছেন না এখানে। That's why this is called a non-linear device or non-linear system. আপনি এখন বুঝেছেন আপনারা?
স্যার ইন্ডাক্টর ক্যাপাসিটেন্সের ক্ষেত্রে তো আমরা স্যার মানে এক্সএল ইকুয়াল টুয়াইস বাই এল দিয়ে করলাম,
কোনো সমস্যা নেই। আপনি এখানে দেখেন আমার তো এল এর সাথে রিলেশন না, এফ এর সাথে রিলেশন না, অথবা লাইক এল এর সি এর সাথে রিলেশন না। আমাকে যে রিলেশনটা দেখতে হবে, হোয়াট ইজ দ্য রিলেশন বিটুইন ভোল্টেজ এন্ড কারেন্ট। দ্য ভোল্টেজ এন্ড কারেন্ট রিলেশন ইজ স্টিল লিনিয়ার, y = mx আকারে আমরা লিখতে পারি। বাট এই ডায়োডের কেসে দেখেন আমরা কখনো y = mx আকারে লিখতে পারি না। যখন লিখতে পারি না তখন এটাকে বলে লিনিয়ার ডিভাইস না। বাট যদি ডায়োড পড়তাম তাহলে দেখতাম, যদি সার্টেন কন্ডিশনে কিছু রিজিয়নে আমি বলতে পারতাম যে ইকুয়েশনটা দেখতে একটা লিনিয়ার, মানে ডায়োড বিহেভস অ্যাজ এ লিনিয়ার ডিভাইস in a small region and other cases it's a highly non-linear devices. But এটা হচ্ছে আপাতত আমার না পড়লেও হবে, ঠিক আছে? ওটা পরবর্তীতে হচ্ছে আমরা যখন ডায়োড পড়বো ইন ডিটেইলস তখন হচ্ছে দেখলেই হবে, ঠিক আছে?
বুঝতে পেরেছি।
আর কোনো কোশ্চেন আছে? এই ব্যাপারে কোনো কোশ্চেন আছে? So now the question is like, how do you actually deactivate the sources, because only one source will be active at a time. So this idea was the same of whatever we have learned in DC circuit or triple 101 courses. So if we have a voltage source and if we want to actually deactivate it, so voltage source value has to be equal to 0. So when will we get actually 0 volt? So 0 volt means it's a short circuit. Means if I connect actually let's say what is it called, a voltmeter across these 2 points, what would be the reading? The reading would be 0, right? Because this point and this points are the same point. So if I take the voltage difference between these 2 points, so let's say this point is A and this point has to be A because there is nothing connected in between. So the voltmeter is connected between VA minus VA. So the response would be VA minus VA. So basically it would be 0, or that's why this is called a short circuit. So we all know that one. So if I want to actually deactivate something, I need to make it short, means I'll just replace by a short circuit or a single line. Is it clear? You all know that?
Yes, sir.
Probably if you are having a physical lab or maybe in L levels, you have seen actually voltmeter, ammeter, this sort of things. Similarly, how would we actually deactivate a current source? So if I have a current source, and we want to deactivate that current source, how do we actually deactivate that current source? If we set that value to 0, so how do we actually get a current that there is no current? We must to actually create a discontinuity. Here, if this circuit is not connected, means this part and this part are not connected, the current passing from this section or this segment to this segment has to be 0 because there is no actually wire connected or that connection. So similarly, that will be applying here. So, and this is called short circuit. Sorry, this is called open circuit. This is called open circuit. This is called open circuit, something like this. So similarly, if I have a actually current source, current is passing from A to B side, but if I want to deactivate that one, so just leave it blank, means just disconnect this 2 actually points. So this is called the open circuit or something like this. So do we actually know this thing? We had learned this thing, right, in DC circuit?
Yes, sir. Of course.
Yes, sir.
Perfect. Now we'll be having a real example that we'll try our best to actually solve in details using superposition theorem. So now you check this here. We have a system with 2 sources. So one is the voltage source, another is the current source. My target is to calculate the responses. So as I said earlier, using superposition theorem, we can calculate only current and voltages. Now in the exam I said, find the current as well as what is the power across actually the resistance. Can we calculate power using actually superposition theorem?
Sir, we will calculate power at the very end then.
Okay.
First we have to find the current, then...
No problem. You have calculated current and everything. Then is it possible to calculate power using superposition theorem? No, because
No.
the power is not a linear relation. But what he mentioned, that is correct. First, we'll calculate the total current, means IR. We'll calculate the IR using superposition theorem. So if I know the total IR and we know the R, then we can calculate power by using actually I square R. But that IR is the total responses, not the responses coming from actually this voltage source or this voltage source.
Yes, sir.
I will actually explain that one later on once again. So if I want to calculate the current passing through this, while the circuit is having actually 2 sources, before I actually move on to the solution, since all the voltage and current sources are given with in terms of actually phasor, are they having the same frequency or different frequency? Can you put a comment?
Sir, right
on it?
now they are
It's
having same
it's not
frequency.
Same
clear here.
frequencies. All right. Yeah, same frequencies, right? That's why we could actually write down the phasor format. otherwise it's impossible. So if this is the case, if this is the case, first consider any source is actually active. Let's say the current source is active. So if the current source is
কিন্তু
active, বলেন।
স্যার এখানে তো সাইনোসয়েড ছাড়া তো বোঝার উপায় নাই
Acha,
যে
no problem. I will actually discuss that part again. First, we'll solve this, and we'll be having that like discussion later, inshallah. So, if we have actually two sources, so the superposition theorem states that at a time we will be having only a single source. So let's say the current source is active, so we need to deactivate that voltage source. So how would you actually deactivate voltage source? By just replacing a short circuit. The voltage source can be deactivated by using short circuit, and current source will be deactivated using open circuit, or like this. So if I deactivate that segment, the circuit looks so easy. Now my target is to calculate what is the current passing here, right? Passing through this component. So that would be so easy. That would be so easy. Okay. So now, what would be the answer? So how would we actually solve this one? You may use current division rule. You may use node analysis. You may use other method as well. So like the loop analysis, whatever. Tell me, which one would be like the easiest one. Even you can use actually source transformation. That is the easiest probably.
Current division will also be
No problem. It's up to you. It's up to you. If you here we have used actually current division rule, but since we have used current division rule here, I'm trying to say that in other methods we can get the same results, like whatever you find it actually convenient. So what you could do, you can apply node analysis here, then you'll get the node voltage here, node voltage here, and then you'll get the current passing through here. Otherwise, the easiest thing, this current source and this impedance are connected in parallel, right? Because we cannot change this one. So if they are in parallel, if I use the source transformation, then can we use like this?
Yes, sir. It's
like
much easier.
Then it would be a simple series circuit, right?
Yes, sir. Then in the end, we just have to use the KVL.
Yeah, the simple KVL, that's voltage divided by there's all actually summation of the things, right? So
Impedances, yes, sir.
you'll be getting the same results actually. This value is 2 times ZL. This value is 2 times ZL, and this is ZL, and then the value. So you can easily calculate current here. So it's up to you, which method are you using. Even if I was a student, I will use actually loop analysis probably, because I'm really good at loop analysis. So when I was a student, I tried to actually solve everything by loop analysis. So it's up to you, whatever you find it actually easier or convenient, you should actually go for that. So once you actually get the current here, this is not the answer, because that current is coming from this source only. So I need to consider this source now while deactivating this. So how do you do that? So if I have a voltage source, then we'll deactivate the current source. So I'll just let it open. So if it's a series circuit, right? So if it is a series circuit, we can easily calculate this current. So whatever the current value we have got here, then according to superposition theorem, the responses would be the responses coming from the current source and the voltage source will just add up these two. Whatever the results we'll get, that would be the answer. Any confusion here? Hello?
স্যার প্রথম দিকে আমরা যে ফেজরটা ফেজরটা নিলাম, এখানে তো স্যার সাইনোসয়েড ছাড়া তো বোঝার উপায় নাই যে এখানে কোনো ফ্রিকোয়েন্সি একই কিনা।
Perfect. That is a good question. Like, since the voltage, his question is like, since the voltage and currents values are given in terms of phasor, how do you know that they are having the same frequencies, and what would be the frequencies? The answer is correct. Since it's a phasor, that sinusoidal value we have learned that E equal to 20 root 2. It's root 2, right? Because it's the peak value. Then let's say this is sine, this is omega times t, means 2 pi f. This is 2 pi f and plus 30 degree, right? So this is the sole actually expression. If this one is the sole expression, we don't know that frequency because frequency is not given. If I actually provide frequency equal to, let's say 100 hertz or 1 kilohertz or 1000 hertz, let's say. So then this one is having the same frequency, this one is having the same frequency. Means if I write down the sinusoidal equation for the current, that is 2 root 2, then sine omega t plus 0 degree. So that's how what I wanted to say, that these two are having the same frequencies. এখনো মনে হয় একটু ডিফারেন্ট লাগছে না? হ্যালো,
জি স্যার, একটু
আচ্ছা দু একবার প্র্যাকটিস করলে হয়তো বা ঠিক হয়ে যাবে। হ্যাঁ, আমি বলতে পারি যে ডিফারেন্ট ফ্রিকোয়েন্সি থাকলে কি প্রবলেম হবে, বাট আমি জানি না এটা হচ্ছে আপনাদের কোর্সের অন্তর্গত কিনা। যদি আপনারা জানতে চান, আই ক্যান টেল, বাট এটা আপনাদের পরীক্ষার অংশ না। এখন আমার কি বলা উচিত কিনা আমি সেটা বুঝতেছি না।
প্রবলেম নেই স্যার,
প্রবলেম নেই,
whatever sir,
অবশ্য টাইম লেগে যাবে। ঠিক আছে, তাহলে অন্য এক সময় ওটা ইনশাল্লাহ করব, যখন হচ্ছে আপনার যে আমাদের সেশন থাকবে না, যে প্র্যাকটিস সেশন থাকবে, তখন আমাকে বলেন, আমি বলে দিব যে দুটো এক্সট্রা থাকবে। কেননা এটা হচ্ছে আপনার এক্সামের অংশ নয়, আমার এগুলো কভার করতে হবে, আদারওয়াইজ আপনার জন্য লাস্টে সেলফ স্টাডি হয়ে যাবে। সো আপনারা এটা প্র্যাকটিস করে দেখতে পারেন যে আপনি এই অ্যানসারটা পাচ্ছেন কিনা। নাও we have a similar actually question, but now we have a DC source and we have an AC source. So but our target is to calculate what is the total voltage response across that resistor. So if I have only DC source, can anybody tell me at DC source what is the frequency?
Sir, there is no frequency.
There is no frequency. What does it mean? Frequency is zero.
Like zero,
Let's say
zero frequency. Yes.
perfect. So let's say I have a AC source. The name is AC source, but I want to actually make it behaving like a DC source. So how could I do so?
Sir,
By setting the
we
frequency
just
zero, right?
frequency
turn
zero, yes,
the frequency 0.
Yes. Then it will behave as in a DC source. In reality, it doesn't behave like a perfect DC source, but yeah, at least in theory, we can actually make it as a DC source. So if this one is the case, think about this. We have a hybrid system, means the DC source as well as actually AC source. So the thing is, first we will consider, let's say, the DC source only. So if I have a DC source, so we'll actually make it short. That E2 will be short. But since the frequency is now, okay, now I can answer your question. What is the frequency of this one? For this actually source, what is the frequency? This is not mentioned, but the frequency is F, because if I write down the sinusoidal for this one, what would be the sinusoidal response? 4 root 2, then sine
omega t, that's all.
omega, or if you are writing omega, or 2 pi f times
Yes.
t plus 0 degree, right?
yes, sir.
Hello. So it is
Yes, sir.
it is having a frequency. But how about DC? If I write down let's say this is the phasor 12 0 degree, this is the phasor, what would be the sinusoidal response of DC? Will there be any sinusoidal response? Because DC means there is no frequency. So if I put in the frequency, and then it's nothing but the 12, right? Hello.
Yes sir.
Okay, if this is 12, is it having a frequency? Hypothetically, that frequency is 0. Yeah, let's say, yeah, you are right, there is no frequency. But since we are trying to say what will happen if we have two different frequencies, now we have actually a practice problem that can be actually explained through this. So we are having two different frequencies, right? So if I have two different frequencies, do you think XL and XC will behave in the same way when this
No, sir.
frequency is
They
present
depend
and this
on
frequency is
No, sir.
frequency?
No, sir. They
Because
depend on
now we
frequencies.
perfect. The thing is, if we have two different frequencies, and if we are applying actually superposition theorem, whenever we are considering this source, the whole circuit will be tuned at this frequency. Whenever this source is active, the whole circuit will be tuned at the different frequencies. Is it clear? This is the actually
Yes,
statement
sir.
I wanted to make. Now you do understand. But in reality, whenever you connect two different frequencies and you wanted to get some output responses in circuit lab, then you'll get the response directly, because the whole circuit will adjust in such a way, means after sometimes it will be getting some steady actual response that can be actually found in theory by using actually superposition theorem. And you cannot use mesh analysis or loop analysis there if we have two different frequencies. Do you understand why superposition theorem is important in solving actually AC circuits?
Yes, sir,
But
exactly.
this is not a part of your course, okay? This is just for your information, so you should have a better idea. So now get back to the problem only. So we love to solve the questions, right? Like we love to solve only the maths, how to solve the maths, but sometimes it is better to have the clear concept. So now we have a DC source. Let's say the DC source is active. That means the frequency is 0. So what will be the fate of inductor and capacitor? Let's check it out. What is the responses of inductor? Inductor equal to 2 pi FL, right? What is the reactance of capacitor?
1 by 2 pi FC.
1 upon 2 pi FC, right? So if frequency is 0, in DC, what is the frequency? 0, right? XL equal to how much? 0, right? And what is XC? The impedance or reactance is
1 by 0
infinity.
infinity.
So tell me, 0 impedance means what is it? Open circuit or short circuit?
Short circuit.
Perfect. And what is the infinity in resistance means? It's a half.
Sir, open circuit.
Open
So
circuit.
it's an open circuit. So in this is actually shows in DC that inductor and capacitor will never work. That's why when you had actually triple 101 courses, had you actually studied that capacitor or inductor things other than
Yes, sir.
solving?
RLRC circuit. Yes, sir.
That is the transient response. So this is a different thing. But when you had actually solved that loop analysis or mesh analysis, node analysis, did you have the capacitor inductor there? No, because
No, sir. No, sir.
because that is a DC source. At DC, the inductor will be like short circuit because XL equal to 0, and the capacitor will behave as an open circuit. So since the actually impedance is actually infinity, so that's what we have seen here: the X equal to infinity and the XL equal to 0. So inductor will be behaving as a short circuit, and capacitor will be behaving as an open circuit. So what would be the circuit configuration here? So when only the DC is active, that voltage source will be short, and then resistance will be there. How about this capacitor? It will be open, right? Hello?
Yes, sir.
Yes, sir.
And this inductor will be short, and
Short.
there will be only
Yes, sir.
resistance. Now check it out. This circuit looks so easy. Like only voltage source, one resistance in parallel, and then there is another resistors. So you can apply many actually formulas. It's up to you, which formulas are okay. You can use actually loop equation, that is the easiest thing, or you can use voltage division rule using this resistance and this resistance are parallel, and later on you need to actually use some other actually formulas. So it's up to you, how you actually solve that one. You want me to solve this one? This
No, sir,
simple
it's
circuit
easy.
can be solved in many ways, like loop equations, node analysis, whatever you find it actually okay. So I think this is so simple. So you will get the response across actually that resistor. So once you get that response, that is not the answer, because you had another source, the voltage source, so the AC source. Now for the AC source, when that AC source is active, all you have to do is to deactivate this source. Like if I deactivate this source, will that capacitor inductor works? Because that frequency is no longer 0, right? For that AC source, frequency is no longer 0, so capacitor inductor will behave normally. So we have this sort of circuit. So we'll have this sort of actually circuit. Now we have this sort of circuit. So these two capacitors are in parallel, so you can actually make it to one. And then if you apply actually some what is it called? These two are in series. So if you apply some sort of loop equation or node analysis, whatever is okay, you will get the response. Can you hear me? Is my
Yes, sir.
internet connection okay? Because it's
Yes, sir,
showing
it's
a
okay, sir.
single bar in actually that Wi-Fi section. I'm not sure.
Sir,
Okay,
we can hear you
okay.
clearly.
Thank you so much. So do you understand like how to solve this one? Do I need to solve this one?
No, sir.
No,
It's
sir.
really easy.
No,
So
sir.
I try not to focus on that calculation, because it will take much time, so I cannot cover everything. But you should actually give it a try at home. It would be a good practice for you. All right. So give me a second. Thank you. Yeah, sorry. So that would be the case. So once you actually get to know what would be the voltage, because of that actually voltage source, all you have to do is to just add up that two responses, nothing else. So like whatever you got here from the AC source and whatever we got from the DC source would be the answer. Now the question is, can you hear me? Hello?
Yes, sir.
Yes, sir, we can hear you, sir.
Okay, now the thing is, I'm not solving the things. Just like imagine there is actually current source. This is another actually AC source, not DC, with a different frequency. Let's say this frequency is 1 kilohertz, F1, and this is another frequency is F2, that is 2 kilohertz. And these two frequencies are not equal. Whenever this one is active, the whole XL and XC will be changed with respect to 2 kilohertz, because the formula would be 2 pi F2L, means XL formula should be 2 pi F2L, and XC formula would be 2 pi F2C. Do you understand that term? And then we'll solve the math.
Yes, sir.
And when this one will be active, then the XL value should be 2 pi F1L, and XC value would be 1 upon 2 pi F1C. And later on, we'll get the response here, means V3, for this and this. But the final answer would be really interesting. Now check it out. The final answer, one is DC because we had a DC source, and we had a AC response because we had another AC actually source. But if we had two different AC sources, then we'll get two terms like this. But the expression would be some value sine 2 pi f1t, then angle. And another thing is value followed by sine 2 pi f2t, then the angle. Do you understand that thing? This is called some sort of harmonic, but these are not the part of your syllabus. So I will rather skip that things. Is it clear?
Yes, sir, it is
Hello?
clear, sir.
Okay,
Yes, sir.
then I will actually end our session here. I will actually end a bit early. So I will try to actually cover the Thevenin-Norton theorem and the other theorems in the next class. Probably these are same as whatever we have learned in DC circuit. Any question here? Do you have any question?
No, sir.
No, sir.
No? Do you understand what I wanted to actually teach, or I'm really difficult to understand?
Yes, sir, I have understood.
How about other students?
Yes, sir.
Yes, sir.
It's really easy,
understood you.
actually. Not that much hard,
Thank
actually,
you so
except
much.
for the
Yeah.
non-linear part.
All right. Thank you so much for your actually feedback. So see you again on Sunday, right? The next Sunday. Okay. Okay,
Yes, sir.
and best of luck for your 2024 exam. So for that exam, I'll put some question from the series resonance part as well as actually parallel resonance part.
Sir,
So
what experiments are the included? What experiments are included as the syllabus for 22204? Actually, like experiment number 6 is also included.
203L, sir.
it would be
Yes.
good for you if I include experiment 6 like the parallel resonance things, because both the formulas would be there. So what I suggest, you should learn how to actually calculate bandwidth if the carrier frequencies are given,
Bandwidths
or the
are
quality
easy,
factor.
yes, sir.
Yes, the question would not be difficult. That is not my target.
And what about the MCQ, sir? What are the topics are going to be covered?
The MCQs would be quite simple. Like if I provide you some values, there would be four choices, like or true false, something like this. I have not set my part yet. By today, I have to do that. So probably after lunch, I will set some question.
Okay,
But the
so
question would not be difficult. But you must use your brain. That should be the thing, inshallah. Okay.
okay, sir.
Okay.
Okay, sir. Thank you
স্যার
so much. So pray
এক্সপেরিমেন্ট
for us.
6টা স্যার ফিজিক্যালি মানে সবগুলো ফিজিক্যালি অথবা সবগুলো সিমুলেশন হলে ভালো হতো, মানে কিছুটা
Physically,
আচ্ছা,
আমি
সামনের
আপনার
বুঝেছি।
যে
দিকে।
এক্সপেরিমেন্ট 6টা অ্যাকচুয়ালি আমাদেরকে পড়ানো হয়নি স্যার। আপনি জাস্ট হচ্ছে অনলাইনে ক্লাস নিয়েছিলেন অ্যাকচুয়ালি। আর আমি এটা
হ্যাঁ।
পার্টিকুলারলি সিমুলেশনও করিনি, এখন দেখে নিতে হবে নাকি এর জন্য স্যার জিজ্ঞেস করতেছেন।
ও আচ্ছা, that is so easy, So
Yes.
same formula, series resonance সার্কিটের মতো, শুধুমাত্র বিহেভিয়ারটা উল্টা। লাইক যখন আমরা কারেন্টটা ম্যাক্সিমাম পাই সিরিজ রেজোন্যান্স সার্কিটে, প্যারালাল রেজোন্যান্স সার্কিটে কারেন্টটা মিনিমাম থাকে রেজোন্যান্সে। সো একটু কি হচ্ছে ডিফারেন্স। আপনারা ওই সিমুলেশন করতে 5 মিনিটও লাগবে না।
ইয়েস স্যার, একবার সার্কিট দিলে সিমুলেট করা স্যার ইজি।
হ্যাঁ, দ্যাট শুড বি ওকে।
ওকে স্যার, সো
অলরাইট।
তাহলে স্যার এক্সপেরিমেন্ট 6 পর্যন্ত দেখে রাখবো নাকি স্যার?
হ্যাঁ, আপনারা দেখে রাখেন। তারপরেও যদি আপনাদের প্রবলেম হয়, আপনারা এইদার হচ্ছে সবচেয়ে ভালো গুগল ক্লাসরুমে যদি আপনারা কমেন্ট করেন। কারণ হচ্ছে আপনারা সবাই ইমেল পাঠান আমাকে। আমার এখন ইনবক্সে 655 ইমেল। সো আমি কোন ইমেল চেক করব, কোন ইমেলটা ইম্পর্টেন্ট, কোনটা রিপ্লাই দিব, ইটস রিয়েলি ডিফিকাল্ট ফর মি
ইয়েস
টু
স্যার,
মেক
আন্ডারস্টুড স্যার।
রিপ্লাই অল অফ দেম। বাট আপনারা যদি ক্লাসরুমে কমেন্ট করেন, তাহলে আমি বুঝবো যে সবার কমেন্টটা হচ্ছে ওই একটা কোশ্চেনের বেসিসে। সো আমি একটা ইউনিফাইড রেসপন্স লিখতে পারি। ঠিক আছে? এই কারণে অনেক সময় আমি কতগুলো ইমেল দেখার পরেও আমি রেসপন্স করতে পারি না। ঠিক আছে? আপনাদের যদি কোনো কোশ্চেন থাকে অথবা যদি না বোঝেন এই পার্টটা কিভাবে হইলো অথবা কোথা থেকে আসলো, সেটা এট লিস্ট হচ্ছে সিরিজ রেজোন্যান্স এবং হচ্ছে প্যারালাল রেজোন্যান্স হচ্ছে যে লাস্টের 3টা এক্সপেরিমেন্ট, আপনারা আমাকে বলবেন। ইনশাআল্লাহ আই উইল ট্রাই মাই বেস্ট টু ক্লারিফাই ইনশাআল্লাহ। ঠিক আছে?
ওকে স্যার।
কারো কোনো কোশ্চেন আছে স্যার? Probably not. Then we'll
No,
end our session here. Thanks for joining once again.
yes, sir. Assalamu alaikum, sir.
No problem.
Have a good day,
Walaikum
sir.
assalam. Have a good day.